Good morning students. Welcome to the class 9. Today we are going to discuss the textbook page number 2 and 3, speed and velocity. Can you recall what is mean by scalar quantity and what is mean by vector quantity? Let us discuss. Dear students, scalar quantities are those which need only magnitude to get expressed, while vector quantities need magnitude as well as direction to get expressed. Second major difference in the scalar and vector quantity, we can say that scalar quantities are one dimensional, means they need only magnitude, they need only one thing to get expressed, while vector quantities are two or three or multi-dimensional. Third important difference between the scalar and vector quantity, we can note that the scalar quantities can defined by number and unit, while vector quantities need to get defined number, unit and direction. The fourth point we can take to differentiate scalar and vector quantity, their examples. Examples of scalar quantities are like mass, length, distance. Since distance is calculated with the length, distance need only magnitude, it is the scalar quantity. Time and so on. While vector quantities includes displacement, velocity, acceleration and so on. So dear students, by discussing this all the points, you might have got the answer for your second question given in can you recall. Which quantities? Distance, speed, velocity, time and displacement are scalar quantity and which are vector quantities. So it is easy for you to distinguish and differentiate the quantities. So here once again we'll repeat. Distance, speed, time are the scalar quantities, while displacement, velocity are vector quantities. So dear students, let's move to the next point of the lesson, that is speed. Let us take an example. If suppose here is the point A and this is the point B, and a vehicle moves along the straight path from the point A to the point B. Say for example, this is the specific distance between the 2 points. Say for example, here it is 5-meter distance, and the vehicle reaches to cover this 5-meter distance 2 minutes. It covers distance in the 2-minute time. Then we can say that the speed of vehicle to reach from the point A to the point B is 5 meter in the 2 minutes. So here we can define speed as, we can get the idea clear cut about speed as, the speed is nothing but the fastness or slowness of the body when is moving from the 2 points. We can define speed as distance traveled by body in the unit time. So we can formulate speed as speed equal to distance traveled upon time taken. Say for example, speed is v, then distance is s and time is t. Here v is the speed of object, s is the distance traveled, and t is time taken. Suppose a car travels from the point A to the point B. The distance between these 2 points is 100 kilometers, and the time required by the car to reach to the point B is 4 hours. Then we can say speed of the car is equal to 100 upon 4. If you will divide this, it will be 25. Then 25 kilometers per hour. So SI unit of speed is meter per second. We can also express CGS unit as centimeter per second. Also we can express the unit of speed in minutes or hours. Remember, speed is a scalar quantity. It has no specified direction. So, speed is a scalar quantity. When we say that speed of vehicle is something, then we need not to mention its direction. Hence, speed is a scalar quantity. So, from this all discussion, it is clear to you what is speed?
Can you recall? 1. What are vectors and scalars? 2. Which of the quantities distance, speed, velocity, time and displacement are scalars and which are vectors? Speed is equal to total distance travelled upon time required.
Speed of car or speed of any object gives us idea about how fast or slow an object is. But it is not able to explain the direction of object. So for that, the next quantity we need to get explained, that is velocity. So let us move toward the next quantity, that is velocity. So to know that exact position of car, if suppose a car starts to move from the point and it reaches to the point B, which is at the distance of 100 kilometer and it requires the time 4 hours. A car starts from the point A and it reaches 100 kilometers in 4 hours. Now, where exactly the point B is located? For that, we need to explain the direction. Suppose the direction is due south, then point B can be here. If it is due north, then the point will be there somewhere. If it is here, then the point will be here. So, distance traveled by a car in the 4 hours in a particular direction is nothing but the velocity. So, we can say here, what is velocity of an object? So, velocity is the distance traveled by an object in unit time in a particular direction. So velocity can give you clear-cut idea about the direction also. From this we can say that velocity is a vector quantity. Here, point to be noted, unit time can be 1 second, 1 minute or 1 hour. So when you are expressing the unit of speed or velocity, it can be in unit second or it can be in unit minutes or it can be in unit hour or it can also be unit year. Now if you you are taking the unit year, it is for the celestial body. If you say that from one star the light ray travels in a particular direction to the another star or satellite or planet, then the distance, or we can say the velocity of light, can be measured with the larger unit, that is the year. So we can formulate here velocity as velocity is equal to displacement of object in the particular time, in particular direction. So here one more important point about velocity you can understand, it is related to displacement.
The distance traveled in a particular direction by an object in unit time is called its velocity. Here, unit time can be 1 second, 1 minute, 1 hour, etc. If large units are used, 1 year can also be used as a unit of time. The displacement that occurs in unit time is called velocity. Velocity is equal to displacement upon time. Always remember, 1. The units of speed and velocity are the same. In the SI system, the unit is meter per second, while in the CGS system it is centimeter per second. 2. Speed is related to distance, while velocity is related to the displacement. 3. If the motion is along a straight line, the values of speed and velocity are the same. Otherwise, they can be different. Velocity is the displacement that occurs in unit time.
Now let us take an example which is given on the page number 1. That Sheetal's house, Sangeeta's house, and the school. So Sheetal moves the distance from her house to Sangeeta's house, that is 500 meters. While Sangeeta's house and the school is 1200 meters. So if suppose distance travel is the straight line between Sheetal's house and school, then it is 1300 meters. This straight distance, the straight distance from Sheetal's house is 1300 meters. While when Sheetal moves to Sangeeta's house and then to school, that is 1200 meter plus 500 meter, that is 1700 meters, the total distance. Is 500 plus 1200, that is 1700 meter. So if suppose you need to calculate Sheetal's speed along path A. मुस्तनसिर जरा चलो जाएंगे ना, मम्मी आवे छे 5-10 मिनिट में, घंटी मत मारजो. Now let us calculate Sheetal's speed along path A. Say this is the path A. This is the path B. Then we can say that Sheetal's speed along path A is equal to distance upon time equals 500 meter upon 5 minutes. Suppose Sheetal reaches in the 5 minutes. Then the speed of Sheetal is 5 ones are 5, 5 ones are 5. That is 100 meter per minute. Sheetal moves from her house to Sangita's house with the speed 100 meter per minute. Then Sheetal's speed along path B equals distance upon time. That is 1200 meters upon 24 minutes. Say for example, she takes 24 minutes to reach this distance. Then her speed along this path B is 50 meters per minute. We can divide this quantity, then you can get 50 meters per minute. Now, if you will calculate average speed of Sheetal, from this speed we can calculate average speed Sheetal's average speed, then it is equal to total distance upon total time equals total distance is 500 plus 1200 meters and the total time is 5 plus 24 minutes. Then we can say that 1700 meters upon 29 minutes. On dividing, we will get the value 58.6 meter per minute. While Sheetal's velocity can be calculated by displacement upon time. So displacement is 1300 meters, which is the shortest straight path from Sheetal's house to school, and the time taken is 29 minutes. So it is 44.83 meter per second.
In the first example, the straight line distance between the houses of Sheetal and Sangeeta is 500 meters, and that between Sangeeta's house and the school is 1200 meters. Also, the straight line distance between Sheetal's house and the school is 1300 meters. Suppose Sheetal takes 5 minutes to reach Sangeeta's house and then 24 minutes to reach the school from there. Then Sheetal's speed along path A is equal to distance upon time, which is equal to 500 meters upon 5 minutes, which is equal to 100 meters per minute. Sheetal's speed along path B is equal to distance upon time, which is equal to 1200 meters upon 24 minutes, which is equal to, speed is equal to total distance upon total time, which is equal to 1700 meters upon 29 minutes, which is equal to 58.6 meters per minute. Sheetal's velocity is equal to displacement upon time, which is equal to 1300 meters upon 29 minutes. Sheetal's velocity is equal to 44.83 meters per minute.